The following example is about motion, and we're going to use integration to find our answer. A ball is thrown vertically from the top of a building that is 24.5 meters high and hits the ground 5 seconds later. What initial velocity, v0 equal v at time 0, was the ball given? The information in the question states that we're at the top of a building. So at time equal to 0, we know that the position is 24.5 meters high. Hitting the ground 5 seconds later tells us that at time equal 5 seconds, 5.0, then the position is equal to 0 meters. We're looking for the initial velocity. Since the ball is thrown, it is under the influence of gravity once it's released, and we derived in class that the velocity of any object under the influence of gravity as a function of time is equal to the initial velocity minus 9.8 t. If you don't recognize this, try starting the problem by integrating the acceleration due to gravity, which is negative 9.8. Integrate that, and then use the fact that v at time 0 is v0, and you should arrive at this conclusion. So we'll start from here. We know things about position, so to find position we have to integrate velocity. So the position as a function of time then is equal to the integral of v0 minus 9.8 t with respect to time. Integrating gives us v0 t minus 4.9 t squared, or 9.8 t squared over 2, plus a constant. And that is the position as a function of time. Now we know at time 0 the position is 24.5, so replacing t with 0 tells us that 24.5 has to be equal to v0 times 0, which is 0, minus 4.9 times 0 squared, which is 0, plus c. So therefore c is equal to 24.5. Now we have the expression s of t equals v0 t minus 4.9 t squared plus 24.5. Given that the position is 0 at time 5 means we can put 0 in for s and 5 in for time, allowing us to find v0, which is the initial velocity, which is what we're looking for. So 0 equals v0 times 5 minus 4.9 times 5 squared plus 24.5. Moving the 24 and the negative 4.9 times 5 squared to the left and simplifying gives us 98 equal to 5 v0. Dividing both sides by 5 tells us that v0 is equal to 19.6 meters per second.